Okay, 6.2, number 13. Oh, yeah. So this would be more of an FRQ style problem, if that helps any. 13, in the figure, a 1.34 kilogram ball is connected by means of two massless strings, each with a length of 1.7 meters, to a vertical rotating rod. So do you guys understand this? So there's this rod here, right? So that rod is just spinning on some sort of motor or something, and then there are two ropes on it that both have an equal length, L. It tells you that they're separated here by a distance d, and then there's this ball attached to the end, and it tells us the mass of the ball is 1.34 kilograms. Oh yeah, and it tells you d is 1.7 meters also. What would... Yeah, that's weird. All right, I'm going to keep them separate just because even though they're... D and L are both 1.7 meters, so I don't know why they differentiated between them. Okay, so anyway, it says the strings are tied to the rod with separation D, and they're taut. So the word taut just means tight, yes? Yeah. Incidentally, the word taut and the word taunt, not the same word. Sorry. I know people who mix those up, and I always go, that's not the right way to say that. Okay, anyway, the tension in the upper string is 35 newtons. So let's give these names. Let's call this force of tension 1. And let's call this force of tension 2. Cool? All right. So then we got to find the tension in the lower string and blah, 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 blah. Okay, so if you had to guess, which of these two ropes do you think is probably tenser? Which one has the higher tension? The top one. Why? What's the top one doing? It's of the two strings, it's the only one supporting it, right? Against gravity, right? So the Y component of tension 1 has to be supporting the gravity, yes? Yep. All right. So in terms of solving this, the first question wants us to find T2. So what's your knee-jerk reaction? What should we do? Split them up by components. We want to make a free body diagram for the ball, right? Okay, so let's do that. So here's the ball. So my force of gravity is 1.34 G. Yes? Force of tension 1 vertical. Force of tension 1 horizontal. Force of tension 2 horizontal. Force of tension 2 vertical. So, does that make sense? Yes. Everybody good? All right, now, we got to do a little bit of trig, but because our sides are equal, Josh pointed out, since all three sides are equal, it's just going to be a 60, 60, 60 triangle, right? Yes. If you didn't know that, then you would just draw in a little angle here, and you'd say, okay, well, I know this is 1.7 along the hypotenuse. My opposite side would be half of D, right? So you can certainly find this angle even if it wasn't a 60, 60, 60 triangle, right? Yes. I guess I could just say equilateral, right? Everybody good? Okay. So I think that I ought to be able to find the components of my tension 1, right? Just by looking at that triangle there. Does everybody see that? So my Y component, I know, is going to be 17.5 newtons, yes? Yes. Does anybody know what the X component is? It's 35 times the cosine of 30. What is it? I think I got 30.3. Anybody confirm that? 30.3? Yeah. 30.3 for the X component? Cool. All right. Sarah, what do you got?
Where did you get the 17.5?
It's just Sorry if I was a little too hand-wavy at that. So I know that tension 1 is 35 newtons. The problem told us that, right? And just doing a little bit of trig or geometry or however you want to think about it, we can figure out that this angle here is 30 degrees. Are you good with that? Okay, yep. And then, so here's my x component and here's my y component. So it was just a... Cool? Thank you for asking when I was... All right, everybody good? All right, so we're almost done. Let me do this. My drawing's getting a little bit cluttery here. Okay, so here's what we've got right now. We've got these forces. 30.3 newtons up. No, to the left. Oh, let me do this. Here. That's a vertical force. I'm going to highlight vertical forces in blue. There's a vertical force. And there's a missing one. Right?
Yes.
So does anybody, do we see what we can do?
Yes. Force of gravity.
What has to be true about these vertical forces, you guys? They have to add up to 0. They have to all cancel, right? Because the ball isn't moving up or down at all, right? So, I feel like I can do this. Let's see, 17.5 minus 1.34 G minus the force of tension 2y has got to equal 0, right?
Yeah.
And solve for the force of tension 2y. 4 point what? 3.7. That seems reasonable. Okay. So is everybody good there? All right, now. So, Peter, you said you got tripped up here. What did you try to do next, or were you just stuck?
Well, so I then like continued trying to get the three-body diagram, but then I was thinking to myself, like, there's a force of tension xq which goes that way.
Yep.
But like, I guess. Oh wait, no. I guess I'm.
So here are the mistakes I can see people making. Can I assume that f2x is the same as f1x? No. So there has to be another way of going about finding that tension. You got an idea, Patrick?
The way that I did it was I made the upward, the force applied by the top row upward, 13.1 plus x. It's the force of gravity plus the force resisting from the bottom row going down, right? And then I made the force of the bottom row x, because that's the force of the bottom row going down.
Gotcha.
And I know that the forces are both applied at 30-degree angles.
So your x is the 4.37.
Yeah, but I didn't plug it in yet.
Okay. All right. So I agree that what you're going to do is working, but I think that because you often have a different way of thinking about problems than many people, I'm going to put you on pause for 1 minute if that's okay. And I don't mean that in a disparaging way, because you always, yes, a billion times yes. And let's try to pick up from where we're at here, because I think this is probably, I'm guessing, closer to the way most people processed it. Maggie, you got an idea?
Can you just say sure?
Yeah, using what vector?
Using the L.
No, okay, yes, sort of. So L is a length. Okay, so you don't want to split up the length vector. You want to split up the vector that lies along it, right? The force vector.
Oh, well,
So it's force of tension 2, right?
you can use the L to find data.
Right. Agreed.
Change everything.
Gotcha. Okay, so I think if I'm understanding correctly, what you are saying is that I don't have enough room on my drawing here. This little angle in here is also 30 degrees?
Yes.
By using the L, is that right? Maggie, is that what you were saying?
Yeah.
That this little angle in here is 30?
Yep.
Cool. So let's draw in that tension 2. We're running out of room here. So here we go. So tension 2, force of tension 2. We don't know it, but I know that this angle here is 30 degrees. We just figured out that the y component is 4.37. I guess I should make it negative, right? Because it's downward. So here's an x component. Follow? So we can find that x component. Anybody have it handy?
7.57.
7.57? Good? Do you guys agree we can now find this missing tension just by doing some Pythagorean theorem? Holy moly, is that it? Oh. All right, I'll see you tomorrow. Finish up the We can do more